Hello, Algebra 2. We're going to take a look at Lesson 8.7a, Guided Practice. Now, when you look in your textbook, you're not going to see any information on the lesson that we're actually working on here. This is a review of work we did in Algebra 1 class, where we learned how to solve linear systems in preparation for what you'll see in your textbook for Lesson 8.7. And so when we get to 8.7b in our next session, then you actually will be solving systems that involve some quadratic equations and beyond. So for right now, we're just going to review what it means to solve a linear system to get the ideas brought back into the forefront of our mind on how we use either substitution or elimination to solve any system. So I just want to remind you that when we are solving a linear system, or any system actually, we're looking for the point of intersection. And if it's a linear system, we're looking for the point of intersection for the two lines. So for this particular system, let's say that we had two linear equations given, and we had an equation graphed into this green line and the other linear equation graphed into this blue line. We would be looking for where those two lines intersect each other to find the solution to the system. And whatever that x coordinate and that y coordinate is, that would be what we consider the solution to the system. So this is the point of the solution of the system of equations represented by the blue and green lines. So that's the background behind what we're doing. You're not going to be graphing today. All you're going to be doing is solving a system with this idea in mind, that the two linear equations were given. If we were to graph them, we would be looking for that point of intersection, the one x and the one y value that exists on both of the lines that solves both of the equations. All right, let's see what that would look like. So see if we can remember a little bit from last year. So guided practice A, we're going to solve the system by the method called substitution. Here's our two equations. We're looking for the 1x and the 1y value that would actually solve both of these. If we were to graph this equation, it would be that point of intersection where the two lines cross over each other. So how are we going to do that without a graph? Well, what we're going to notice is that we are told what the value of y is. It is whatever negative 3x minus 2 turns out to be. So what we're going to do is we're going to look at this second equation here, and we're going to rewrite it, but instead of y, we're going to put what we're told y is up here. We're told that y is negative 3x minus 2, so we're going to put that in place of y. My arrow here tells me I'm going to rewrite this equation, and I'm going to write it exactly the way I see it. 5x stays the same, plus, and the 2 stays the same as well. But the y I'm going to replace with what I was told what it was. It's negative 3x minus 2. So instead of y here, I'm replacing this y with negative 3x minus 2 because that's what it is. Y is negative 3x minus 2. And we're still equal to negative 2. Now I'm down to one variable in my equation, so now I'm going to solve it for x to find out the value of x. Then I'll go back and figure out my y value. All right, so here I'm going to use the distributive property. 2 times negative 3 is negative 6. 2 times negative 2 is negative 4. Everything else gets copied. Now I'm going to combine my like terms. 5x minus 6x is negative x. It's negative 1x. It's hiding. Minus 4 gets copied equals negative 2 gets copied. Add 4 to both sides, and I have negative x equals 2. Multiply or divide both sides by negative 1, and I find out the value of x is negative 2. Well, that's great. I know what x is in both of these equations, but I also want to know what y is. So I pick either equation, whichever one looks easier, to put the value of negative 2 in for x to figure out my y. For me, this first equation looks way easier. I'm going to figure out what y is by plugging in the value of x as negative 2. And then solving for y. So that's what I'm doing down here. Notice my arrows. My system of arrows tells me exactly how I'm working this problem out. You might not want to use columns for this lesson. It's okay if you choose to use them, but you might not want to use them because it'll give you space to move to the right and down, and your arrows are going to show very explicitly how you're stepping through the solution. All right, so here I am coming down. Y is equal to negative 3 times, instead of x, I'm putting what I figured out it is, negative 2. So 3 times negative 2, and I'm copying my minus 2 here. Since negative 3 times negative 2 is 6, y will be whatever 6 minus 2 is, so y is 4. Now remember, my goal was to find that point of intersection if I were to graph these two lines. Well, the point where these two lines would intersect if I were to graph them is at negative 2, 4. So x is negative 2, y is 4, solves both of these equations. It makes both of them true. Let's practice with one more substitution solving a system by substitution problem. So here we have these two equations, and they're both solved for y. So since they're both solved for y, I can use substitution very easily. I can choose to do this a couple of different ways, but I'm going to go ahead and say I'm going to rewrite my first equation, but instead of this y, I'm going to put what I'm told y is down in the second equation. I'm told in the second equation that y is 2x minus 3, so I'm just going to take this 2x minus 3 and I'm going to put it up in place of this y because I know it is the same thing as y. So 2x minus 3 equals negative 3x plus 2. I'm just rewriting this top equation, putting 2x minus 3 in for this y. Now I could have equally correctly used the second equation to put negative 3x plus 2 in for this y. And all that would have happened is that these two sides would be reversed. Other than that, it would be the same. All right, let's solve for x. Now that I have it down to one variable, add 3x to both sides, get 5x minus 3 equals 2. Add 3 to both sides and get 5x equals 5. Divide both sides by 5, and I find that x is 1. Pick either of these equations to figure out your y value. It doesn't matter which one you pick, it'll come out the same either way. I'm going to choose this second equation. It just looks slightly easier to me because there's some nice positive values here. Okay, so I'm going to say y is equal to 2 times the 1 I figured out my x is. So 2 times 1 minus 3. I'm just copying that down. 2 times 1 is 2, so y is 2 minus 3, and that means that y is negative 1. So the point of intersection, the 1x and the 1y value that would exist on both of the lines, if we were to graph this, is 1, negative 1. When x is 1 and y is negative 1, in both equations, I will come out with a true statement. Okay? So we practiced 2 problems, solving by substitution. Now let's move into solving by elimination. Again, this is still a review of Algebra 1 concepts, things we learned last year, so you may remember this entirely, or you may be bringing this back to mind as we review it. So we're going to use on the last 2 problems the method called elimination. We're going to solve by elimination. So we want to use this method when we don't have either equation solved for a variable. We're going to go back for a minute and just notice that in both A and B, guided practice A and B, we had at least one equation solved for a variable. This one was solved for y, and in guided practice B, both of them were solved for y. It doesn't matter which variable you're solved for, either x or y. In the event that either one or both of the equations are solved for a variable, substitution's a really good choice. But if you're not solved for a variable, you might want to consider elimination. And here's how this works. We're going to want to add the 2 equations together, because when we add the 2 equations together, we will get another equation that is true. We want to add them together to eliminate a variable. Well, these 2 equations, if we add them together, at first will not eliminate either variable because 2x plus negative 4x doesn't give you 0x, and negative 3y plus 5y, if you add them, you wouldn't get 0y. But if we simply multiply the top equation by 2, well then, multiplying all of the terms by 2, we would have 2x times 2 is 4x, negative 3y times 2 is negative 6y, and 8 times 2 is 16. And then we would have opposites here in the x's. So we would add those 2 equations together, eliminating the x's. How would we choose to multiply by 2? Well, here's our thinking process to figure out what to multiply by so we end up with opposites that we can add out. I ask on the coefficients of the x term, what do 2 and negative 4 both go into? What is the least common multiple of 2 and negative 4? And they both go into 4. I don't even worry about the signs at first. I just look at the numbers without the signs. 2 and 4 both go into 4, meaning that I could create 4x and negative 4x, which is actually what I did, to add together to eliminate the x's. Or I could have said, what do 3 and 5 both go into? Again, I wouldn't worry about the minus and the plus sign yet. 3 and 5 both go into 15. So I could create 15y and negative 15y opposites here. And that would be another way that I could have solved this equation, eliminating the y's. But it will be easier for me to eliminate the x's because in this case, all I'd have to do is multiply by 2. If I were going to create opposites here in the y's, I'd have to multiply both equations by a number. So that would be slightly more complicated. So here I have my opposites and my x's, and so I add them together, we get 0x. Adding my y's together, negative 6 plus 5 is negative 1y. That negative 1 is hiding there. And 16 plus negative 10 is 6. So we're always going to be adding these 2 equations together. I'm going to add that in right now. We're going to add those 2 equations together. It's not wrong to subtract them, but I like to be consistent with the way I work through these so I don't get mixed up. So I always create opposites that I can add together. All right, so I have my y value is negative 6. I pick either equation from my original equations there to plug that negative 6 in for y to figure out my x. It looks like this first equation might be slightly easier. It doesn't matter which one I pick. I pick the one that I think looks easier. So I'm going to bring it down here. 2x minus 3 times, and instead of y now, I'm going to put negative 6 because I figured out y is negative 6. And that's equal to 8 still. And then I'm going to work that out and solve it for x. So 2x plus 18 is 8. Subtract 18 on both sides, and I have 2x equals negative 10. Divide both sides by 2, and x is negative 5. I now have my values for x and y. That's the point of intersection if I were to graph these two equations. And I would graph them as lines, of course, because they're linear equations. The point of intersection will be negative 5, negative 6. When x is negative 5 and when y is negative 6, it makes both of these true. So we found the one x and one value that solves both equations, and that is the purpose of solving a system, to find the one variable, the one value of each variable that will work in both and make them both true. All right, last one, guided practice D. So again, we're using elimination to solve this particular system. And we're going to use elimination because substitution isn't going to be an easy choice. We're not solved for x or y. But it won't be too hard to create opposites here to use elimination. We think, what do 7 and 3 both go into? They both go into 21. I could create opposites 21x and negative 21x, or what do 5 and 4 both go into? Well, 5 and 4 both go into 20. So I can create 20y and negative 20y, and I could eliminate my y's. And in fact, that's the choice I'm going to use. Doesn't matter which one I use. I can use either choice, 21x and negative 21x, or 20y and negative 20y. But the reason I'm choosing the 20y and the negative 20y is because it's slightly smaller. Those numbers are slightly smaller, 20y and negative 20y, compared to 21x and negative 21x. The other reason this will be an easier choice is because I already have my opposite signs. If I were to use 21x and negative 21x, I'd have to multiply one of these by a negative number, which is possible. It just makes it a little more complicated. So here I am now multiplying my top equation by 4 to create my 20y, and my bottom equation by 5 to create my negative 20y. But of course, I have to multiply 4 times all the terms of my top equation, and I have to multiply 5 times all of the terms of my bottom equation. So 7x times 4 is 28x. 5y times 4 is 20y. Negative 12 times 4 is negative 48. 3x times 5 is 15x. Negative 4y times 5 is negative 20y. And 1 times 5 is 5. Okay, now I can eliminate my y's. Goodbye, y's. They're going to be gone. 28 and 15x, when you add those together, gives you 43x. The y's cancel out. Negative 48 plus 5 is negative 43. And isn't this nice? You can divide both sides by 43, and x is negative 1. So although these can work out to be very complicated numbers, most of the problems you're going to be working with will come out to either integers or simple fractions, just so that you don't have to get too wrapped up in all of the complexities of solving a system with all the arithmetic that can be involved. So we would expect some either simple fractions or some integers for our answers. All right, so now I'm going to take this x is negative 1. I'm going to choose one of these equations here. Go back to my original equations. I'm going to plug in negative 1 to whichever equation I choose. It doesn't matter. It will come out the same way because we're looking for the one x and the one y value that will make both of these true. All right, I chose the top one. So 7 times negative 1 for x plus 5y equals negative 12. So I'm just plugging negative 1 in for my x there. That gives me negative 7 plus 5y equals negative 12. Add 7 to both sides. And that gives me 5y equals negative 5. Divide both sides by 5. And that gives me y equals negative 1. Well, it turns out both x and y are negative 1. So my x-coordinate is negative 1 and my y-coordinate is negative 1. So let's just take a moment to make sure that we understand that these values will make these equations true. So 7 times negative 1, negative 7, plus 5 times negative 1, negative 5. Negative 7 minus 5, in fact, is negative 12. So when x is negative 1 and y is negative 1, it makes the first equation true. But it also must make the second equation true. Negative 1 put in for x here would give us 3 times negative 1 is negative 3. Minus 4 times negative 1, which will give us a positive 4. So we would have negative 3 plus 4, which in fact is 1. So these two values for x and y solve both equations and make them equally true. And that's what solving a system is all about, finding the value of the variables that will work in both of the equations. Okay, so now you have a few problems to work on the worksheet. Most of the problems on the worksheets that you see in the lesson you will ignore. You only have a few to practice this way in preparation for the 8.7 lesson that actually is in your book, dealing with some of our conic sections that have x squareds and y squareds. Okay, we'll see you next time.